Hi everybody, we're back. So next talk is Kieran Jacobsen talking about avoiding DNS pain. Go ahead.
Hi everyone and welcome to Avoiding DNS Pain with me, Kieran Jacobsen. Before I start the presentation, I'd like to take a moment to acknowledge the traditional owners of the country throughout Australia and recognise their continuing connection to land, waters and culture. I pay my respects to their elders, past, present and emerging. So as I said earlier, my name's Kieran Jacobsen. I recently joined Focus Software as their head of business systems. I'm leading a team that's supporting our internal IT systems, our infrastructure and a lot of our business processes and working through that to help drive the business to further growth. I've been a Microsoft MVP for the last 5 years and I'm also now a GitKraken ambassador. But enough about me, let's start talking about DNS. So it's my firm belief that DNS is one of these systems that's really underappreciated, and it runs and powers all of our networks and our the internet as we know it. Well, it's underappreciated until it becomes unavailable, and that's when we find ourselves not just as individuals and organizations, but globally in a world of pain. 2021 last year was actually pretty significant in terms of DNS outages. There was pretty much every major player, every cloud provider was impacted at some point in time by a DNS related change or issue. In April, Microsoft and Azure and a lot of dependent services and customers were impacted by a DNS outage that was caused by a coding issue inside Azure's DNS services. In July, customers of Akamai, including Oracle Cloud, UPS, FedEx, Steam, LastPass and Sony PlayStation were impacted by an outage in Akamai's Edge DNS service. September saw an outage with Slack and their DNS services, but these were all overshadowed by what was really an internet meltdown. That was when Facebook, Instagram, Messenger and WhatsApp went down for over 6 hours in October. This outage wasn't actually caused by DNS or DNS change or server issue directly, but networking issues that made those services unavailable. But once again, that helps highlight how a DNS resolution issue can quickly start to cause absolute chaos. The estimate is that Mark Zuckerberg lost millions of dollars. I think it's hundreds of millions of dollars as Meta's stock market value just dropped over that period of time. And of course, not to be left out of the club, AWS had a DNS-related outage as well in December. This one actually had a lot of downstream impact. There was a lot of other IT service providers and organizations that rely on AWS that had outages as well caused by this issue. And all of this keeps building up to this really big challenge that organizations are starting to face around ensuring that, websites and web applications are still resolvable in the event of issues. But there's also been a lot of DNS security concerns as well. It's not just outages we need to think about when we look at DNS. Attacks against DNS have been on the increase year on year. Organizations have been repeatedly warned to be on the lookout for attacks against DNS infrastructure over these past 3 years. 3 years ago, CISA, the American government security agency, they released their very first emergency directive, and that was actually warning organizations and government agencies to take steps to prevent attacks against critical DNS infrastructure. That warning has, in a way, fallen on deaf ears mostly. Security threats to DNS come in a couple of different forms, the most common still being attacks via compromising DNS entries, but the other one that we're starting to see a lot more of is what's called dangling DNS entries. So let's take this situation. We're going to provision a web app on Azure, and it's got the FQDN of app.contodev001.azurewebsites.net. We're going to assign greatapp.contoso.com to route traffic to that Azure resource. Now, after a while, we decide we don't need that application anymore. Somebody's gone into the Azure DNS, Azure portal, and they've deleted that web application. At this point, we've still got that CNAME record that's pointing, so we've got the CNAME record greatapp.contoso.com pointing to app.conto great dev 001, but the underlying application isn't there anymore. And this is a dangling DNS record. This record is now vulnerable to being taken over by some other resource on Azure, some other subscription. It doesn't even have to be the same subscription. Could provision a web service and start to get traffic routed to them. And that's what a lot of threat actors are now looking for, is that they're scanning through DNS site zones and looking for these entries. And so let's just say in this example, some malicious actor, some threat actor discovers this entry. They go into Azure, they recreate app-conto great-dev-001, and now any traffic that's going to greatapp.contoso.com is now landing on a website they control. These dangling DNS entries pose a pretty significant risk. Threat actors can take over over a DNS name, and they can host a malicious website or a malicious web service using your organization's brand. And it's really important that when we start talking about domain names in a business sense, that they are part of an organization's brand. Misuse of a domain is misuse of an organization's brand, and that's linked to the value of that brand and that organization. With a malicious site on a domain like this, they could launch phishing attacks against your customers, cookie harvesting attacks, cross-site scripting, cause bypass attacks. A lot of these things could really significantly damage your brand's reputation. And big and small companies over the internet have all been impacted by these attacks. Several years ago, Microsoft actually had a dangling .microsoft.com domain, and that was a pretty significant issue that they had, and others have seen it as well. It's also worth pointing out it's not just web applications, it's not just CNAMEs that can be vulnerable. There's actually a lot of domains out there that have got dangling MX records, where you could actually go and provision services on some other domain and suddenly have mail flowing through from other domains. So it's not just the CNAMEs you need to be worried about, you need to look at some of the other resource types as well. Another big challenge in organizations is the speed at which DNS changes happen. Now, this image here I usually have in talks about DevOps and DevSecOps, where I talk about the relationship between development teams and operations teams. DNS is one of these things that's often really overlooked when we have an agile or a DevOps transformation. So we end up with environments where there's often strict or very rigid change control processes, especially for DNS changes. They're rarely seen as like a standard pre-approved change. And that's partially because we're sort of subconsciously aware that these things are sensitive, but at the same time, not really thinking them through. And what's the result of all of this change control? Well, making a simple DNS change can often take weeks in some environments. I've seen environments where change control for a DNS change can be several months to make an update to an entry. And that's just not feasible as organizations continue to grow and develop. So when I joined an organization, and I joined Focus in April last year, one of the things that I really find interesting to do is to start looking at DNS zones and start to play a game I called What's This DNS Entry? You might have 50 or 100 or maybe 1,000 DNS entries in a public-facing DNS zone, but do you have clear documentation and traceability about what each one is for? Who requested it? When did they request it? Why did they request it? Are you regularly as an organization reviewing all of your DNS entries and seeing if they're still accurate? How would you even start to work out if maybe somebody's created a DNS entry maliciously in one of your zones? And often, once again, the fallback is change control. Let's just go back to our change management system and we can have a look at, the requests and, see who's changed what. But as we know from the Facebook outage, the teams trying to fix Facebook's DNS couldn't get to their management consoles and their management systems because DNS was down. And so there's got to be some better ways of managing these things so we don't end up with some of these challenges during an incident. And thankfully, there is a better way. And the solution is to start looking at these problems as infrastructure as code, or as I like to call it, DNS as code. Today, I want to talk about DNS Control, and this is a tool that was developed and is maintained by the Stack Exchange team and from a lot of contributions from the community at large. DNS Control is heavily influenced by the experience of the Stack Exchange team in managing websites at a large scale. There's a lot of things, a lot of changes and features that are there based on their experiences with managing DNS outages. So what is DNS Control? It allows us to use a JavaScript-based DSL. Don't worry if you don't know JavaScript. I don't, and I haven't had any problems. But it allows us to use this JavaScript DSL to define what entries should be in a DNS zone. And then from there, it will actually look at a DNS zone in your provider and say, okay, I need to create these entries. I need to delete these entries because they shouldn't be there anymore, and I need to modify these entries. The syntax is really simple to look at. As you can see up on the screen right now, you can see that I've got a domain zone called planetpowershell.com. That's a community project that I maintain. We can see in this DNS zone that there's some SPF records, DMARC, some Office 365 related records. We can also see there's a production website and development website that are hosted on A records as well. And even without many comments, it's pretty easy to just quickly look at this and know what's there in the zone. But we can also add comments to help explain the who, what, when, how, and why of some of these entries. And that really starts to help explain and really communicate why things have been done that way. And that's really important. So say you're going to use DNS Control to manage your zone. What would sort of a standard, let's talk about how making a change to your zone might work. What's sort of a standard approach? So in this example, I want to add a text record, hello.planetpowershell.com, with the content hello linux.conf.au in it. So I'm going to open up my DNS control zone file in my favorite editor. Yours might be something different. In my case, it's VS Code. And I'm going to add in this txt row at the bottom here. And it's really simple. There's just txt, what that name is, and then the content. I'm then going to commit those changes. I'm going to create I'm going to push those to a branch on GitHub. I'm going to create a pull request. I'm here using GitKraken, and they have a built-in PR request feature. So from within inside the tool, you can just go ahead and create your PRs, which I like because it saves a bit of time. But we can start to see with the templates and stuff like that how the process starts to become a bit more clear in terms of change control. So now we've created that change request, that pull request. We need somebody to obviously go in and review that and approve that. And this is where, when we combine something like DNS Control with GitHub pull request templates, we're starting to make our lives as an infrastructure team, as sysadmins, even easier. Pull request templates, they're really great because we can have a template that's got a checklist of what needs to happen to make sure that a change actually meets our internal requirements. In this case, there's a check to confirm there's no dangling DNS entries, that SPF doesn't go over the 10 DNS request limit, and some other sort of checks as well. If this was for an internal zone inside your organization, you might want to have it with some, steps around, say maybe, sending out a notification to users or impacted teams that this change is happening. We can also use DNS Control to provide automated checks. DNS Control comes with two commands: check, which validates the syntax of your files and make sure that they are all correct, and preview. Preview is actually going to go ahead and look at the zones as they are in your production environment and see what needs to be created, what might need to be modified, what might need to be deleted. And it doesn't actually do it, it just tells you this is what I would do if I was told to make the changes. I find this really great because somebody can then propose a change and I can actually go and double check that what they're intending to do actually matches what's actually going to happen. Now, once all of the checks are passed, I've reviewed this change, I can merge it into my main branch. And so that's when our CI/CD process can actually go ahead. In this case, I'm using Azure DevOps and push those changes into production. If I go and look in Cloudflare, which is the DNS provider I'm using for this domain, I can see that that entry has been created. And then if I give it a bit of time for DNS replication and caching, I can see using MX Toolbox's DNS query tool that that record is now available for clients to resolve. So we've gone through a very simple process from somebody proposing a change all the way through to that change being reviewed and then the change being made in a pretty quick amount of time, and a lot faster than most organizations would see a DNS change being made. But there's some other cool features about DNS control that I want to talk about. There's a lot of quality of life and security features in DNS control. There's the SPF builder. It's often called the SPF optimizer in the documentation. This allows us to not only sort of really cleanly define all the parts of our SPF entry, but it will also support what's called flattening of entries. This will basically go in and actually, as it goes to create the SPF record, it will remove some of the DNS queries so that we can try and squeak through that 10 lookup limit for SPF records. In some cases, I've seen it work really well and it's saved queries and helped companies stay under that limit. Other cases, it hasn't worked quite so well. It also has, DNS Control also has functionality to help us build out DMARC policies in a way that's a lot easier to read and understand, as well as our CAA records as well. The CAA builder is a little bit new, still a little bit experimental, but once again, it makes it so much easier to read and understand. DNS Control also has a bunch of features around working with Azure DNS, including alias records, AWS Route 53 alias records, Cloudflare. There's a lot of stuff in there as well. From inside DNS Control, you can turn the proxying of Cloudflare on and off. You can also create page rules from inside Cloudflare. So you can now start to use DNS Control for all of your sort of Cloudflare management as well, and bring it all into one central spot, have all of that documentation, that change control within one spot, which is really, really cool. DNS provider resilience and migration is probably the main reason that Stack Overflow created DNS Control to begin with. When we look at sort of what was behind DNS Control and the Stack Overflow development, it was their experience of having an entire provider just becoming unavailable and needing to be able to quickly set up another provider and know that all of the entries were there and ready to go and that all of their systems would work. And their experience before that was that they had one provider that was a GUI portal, another that had an API, and they were really sort of worried during this outage of, well, have we created everything? All the records there, and that's where the provider resilience inside DNS Control really comes about. So we've got 3 examples here. The first example is example.com. That will actually have 8 authoritative NS records, 4 from Route 53 and 4 from GCP or Google Cloud. And so in that case, you know, clients could go and resolve example.com using any of those 8 authoritative NS records. In example 2, essentially what we're saying here is we want 2 NS records from Route 53 and 2 from Google Cloud. We don't want the full 4. We want to balance it just across 2. In the third example, example3.com, essentially we're saying we want the authoritative NS records to only be from Route 53, But when DNS control goes to configure the zone and push that zone out, it's still going to go and do all of those tasks on GCP. So that basically means that all of the records inside Route 53 and Google Cloud should, in theory, all match up. Now, this is good if you want to just have a sort of a hot spare DNS provider. But one of the big things that I've used this in the past for, and I know a lot of others that do, is actually migrating from one provider to the other. You know, say you were an organization and you're moving everything from running on AWS across to GCP, then, you know, this is a really good approach that you could simply put the Google Cloud DNS provider in, don't make it authoritative, run DNS control, have it set up all of those, and then be able to take your time and review all of those entries before starting to make it the authoritative provider. And then you could slowly move load across to that if you wanted to as well. That's the power behind a lot of some of this stuff. Migration is one of these ones that there's still more work happening in the background, because obviously Stack Overflow team, the Stack Exchange team are seeing more ways to improve that process through their own usage. Before I finish up and open up some time for questions, I've put together some links here that I think will help everybody sort of start on a DNS as code, a DNS control journey. The first two are blog posts that I've written on how you can help protect an organization against some of the infrastructure, DNS infrastructure tampering attacks that are out there, thinking about two-factor, thinking about change control and security controls. And the other is around DNS squatting with a particular focus on Azure App Services. My next entry is a pretty mammoth blog post that I put out a few years ago on setting up DNS control, having it hosted in GitHub, and using what was then VSTS or now Azure DevOps to basically have a full sort of, you know, CI/CD process that's, you know, configuring entries inside Cloudflare and DN Simple. Whilst a lot of that stuff in the content of that post might not be applicable to you, if you're sort of looking at setting it up, it will give you a really good sort of idea and sort of point you in the right direction for starting to come up with your own CI/CD process that meets your organization's needs. My next link there is what I call it's a DNS accelerator package that I've come up with. The idea with that is I've got a DNS control zone file and some CI/CD and documentation and some little helpers to basically be able to buy a domain and have it set up really quickly. And the goal is to also include things like SPF and DMARC and CAA records as well, so that the domain is, you know, on its way to being, you know, having some of these sort of security related DNS entries defined in there from the start. The next two links there are for the official documentation for DNS control. I really recommend that you take a look at their Getting Started guide. I also recommend taking a look at their migration guidance. They have a migration tool that will actually allow you to get a bind file and convert that into a DNS control zone file. It works really, really well. And considering that a lot of some of the sort of third party, you know, the different DNS providers have an export to bind option, it's probably one of your, you know, your best ideas for starting to pick up and use DNS control. Finally, I've got a referral link there to Get Kraken. Basically, if you use that link, both you and I will go into a draw for a $100 gift card, and there's 4 winners every month, I believe. So always a great option to try and get some free Amazon gift cards. Thank you all for listening to my session. I'm going to leave a very sort of old and lame recursive DNS joke there for you all. I'd like to thank you all for listening to me once again. If you want to reach out to me, I'm on Twitter at @Jacobsen, and I've got my website at poshsecurity.com. Thank you all so much.
Okay, thanks, Kieran. We have a couple of questions. First question is, have you tried managing DNS records using other than infrastructure as code tools? And if so, is there anything you've found as particularly standout functionality in DNS Control, and anything you've found DNS Control to lack compared to the rest?
I think the reason that I was drawn to DNS Control is I've tried using Terraform, I've tried using Azure ARM templates and PowerShell and things like that. DNS Control supports so many different services providers and so many different domain registrars that it just allows you to sort of pick up really quickly and just sort of start plugging stuff in. You can, they have a very long list of service providers that they support now, and so you can use the same structure no matter where your domain's hosted. So that's why I've lent a bit more towards DNS Control. I think the biggest challenge right now is some of the cloud providers have very sort of specific entries, and whilst some of that has been added to DNS Control for Azure and AWS and Cloudflare, there's still some that are missing that would be really handy to see. But once again, it's a lot of this stuff is community contributed, so it's up to the sort of people that have time to put this stuff in.
Okay. Another question is, how do you handle dynamically named cloud resources, e.g. load balancer DNS names, which might change at any point?
So there's a few tricks around that. For Azure, there's their Azure alias records, I think they're called. That's one way that DNS Controller can actually talk to Azure and start to bring those things in. And I think there's a similar one for AWS as well, but I haven't played around with that one yet. That's on my to-do list.
Okay, I think that's all the questions we've got. Okay, thank you very much, Kieran.
Brilliant. Thank you, everybody.